Techniques that you have learned previously is going to be incorporated into two questions. One of it will be substitution and one of it will be by parts in integration. So the questions that you did previously, right, will not be a standalone question usually in your end of the year exam. It will be incorporated into one of these two, okay? And these two will surely be tested. So the first one is called integration by substitution, where I make a very complicated equation into a simpler form by substitution. Now the question will usually tell you to sub what? Okay, and here are the 4 steps, right, that I'm going to recommend to you be able to solve substitution kind of question. But before that, you must understand that if I want to integrate anything with respect to x, behind must be dx, right? If I want to change the variable from x to u, I call it fu. Behind is going to be du, right or not? But in order for this to be equal, dx and du, they are not the same thing. So I must multiply by a dx over du over here. This is the first thing that you have to know, as well as all these must be in terms of u. Okay, all these must be in terms of u first. All right, but I'm going to give you a cheat code during this video on how to remember, okay, what to do for this. Okay, so before that, let me introduce to you the 4 steps. Okay, the first step is when the question gives you u equals to x squared, you can make x the subject first by saying that, okay, u equals to x squared also means that x equals to u to the power half. Okay, so this is the first thing, okay, that you are going to do. You can do du dx or you can do dx du, but so your integration must be strong. That means in the sense that, okay, so let's say you're given this. I'm going to differentiate this. This is going to be called du dx. Is equals to 2x. But my du dx must be in terms of u. So next thing is, what is x? 2u to the power of half. So first, make x the subject, okay, and then go and differentiate with respect to x. Make sure your du dx is in terms of x. Okay? So next, I'm going to say that, okay, so now my integral of x over 1 plus x to the power of 4 dx is going to, I'm now going to change everything into u. Integral of u to the power of half over 1 plus x power 4 is u to the power of 2, okay, times. Now I must have a dx du over here, times du, right or not? And what is my dx du? Du dx is this. Dx du will just be the reciprocal. So this is u to the power of half over 1 plus u squared multiplied by 1 over 2u to the power of half du. Don't forget to introduce your dx du in this. Okay? If you find it hard to remember what is your dx du, okay, I'm going to introduce you a cheat code on how to do this. Okay, which is here. Look here. But this method is not generally accepted as in the marking scheme. 1 over 1 plus x to the power of 4 dx is equals to, now before that, I've already differentiated the u. Du dx is equals to 2u power half. I kind of make dx the subject. Cross multiply. Du over 2u power half is equals to dx. This is a cheat code where you can replace the dx with this. Can you see the dx over here? If you cannot remember whether is it times dx du or du dx, then use this cheat code. But you cannot present this. You cannot show this part because dx technically there's no meaning as a subject. So this will still be u power half over 1 plus u squared. Change the dx to du over 2u power half. You will realize it's exactly the same that is over here. Okay, so in this case, 2 methods. Number 1, you remember that if I want to change everything with respect to u, I must introduce a dx du over here. If I want my behind to be in terms of du, because the du and the du technically can cancel away, such that it makes it the same. If you cannot remember, then you split the du dx, make the dx the subject, you replace the dx with whatever u is in terms of u. Okay, now the next part will just be simple already. So once you do your substitution, right, you cancel this, you get a half on the outside. Integral of 1 over 1 plus u squared du. What is this? This is inverse tangent. Is your integration or differentiation technique good enough or not? Is at this point. okay, to be able to identify. Remember, the last part is replace back u equals to x squared. So the final answer is half inverse tangent x squared plus c. Okay, so 4 steps. First, whatever they give you, differentiate first. Make du dx in terms of u. Okay, it could be dx du, doesn't matter. It depends on how the question, okay, wants to give you. Okay, so you have to be flexible. Next one is, remember, if you want to change dx to du, there must be a dx du accompanying here, or you can use this cheat code, split it up, make dx a subject, and then sub it in. Okay, after you do substitution, right, it should be an easy expression for you to integrate. If it's not an easy expression for you to integrate, it means something is wrong. It means you either forgot to introduce your dx du, or there may be some trigo that's going to be involved, which I'm going to talk about. Okay, next. So if you look here, I'm going to do B first. So B is saying that integrate x squared over 1 plus x squared square, okay, dx. And they ask you to use the substitution of x equals to tangent theta. So x equals to tangent theta. There is a reason why they put x over here. Now when you differentiate this becomes dx over d theta, because x is on the left side. On the left side, it replaces, it is like a y. If y equals to like x squared, when you differentiate y, it becomes dy dx, right? Yeah. So this is called differentiating with x with respect to theta. So that's why the notation is dx d theta. Differentiate tangent, secant square theta. Okay? Now, at this part, you must be sharp enough to remember that secant square is tangent square theta plus 1. Okay? May need to use it, may not need to use it, I don't know. But these are things that you have to come to your mind first. Okay? So I'm just going to write it down. We may need to use it, we may not need to use it. Okay? The next thing is, when you have this, when you have a trigo in your substitution, the next thing you must know is you have to draw triangle. Tangent theta is equals to x. X is called x over 1. This is my opposite. This is my O over A, adjacent. Draw a right angle triangle. Theta here. Okay, opposite x. Adjacent 1. This guy is square root 1 plus x squared. Okay, so you come back here. This may not meet or may not need. I just want you to think about, I just want you to have this in your mind, okay, may need and may not need. So if I want to change this to in terms of u, so this will be, or rather in this case, u is tangent. This will become tangent square theta over 1 plus tangent square theta bracket square. dx, okay, remember there must be a dx d theta here times of d theta. So what is dx d theta? That's going to be secant square tangent square theta over 1 plus tangent square theta bracket square. Dx d theta is secant square and d theta. And then you come to here. That is why I would ask you to think of this, because if you cannot think of this, you cannot cancel away. This is the integral of tangent square theta, just keep it. 1 plus tangent square theta square times tangent square theta plus 1 d theta. Can you cancel this and cancel this? Yes. Cancel this, cancel this. Okay, what am I going to get? The integral of tangent square theta over 1 plus tangent square theta d theta. Okay, so over here, you cannot split this because the denominator is 1 plus something. It's not like the numerator is 1 plus something. What is the next thing you have to do? Mathematical instinct. Okay, this is tangent square theta. Again, you look at this. I know that tangent square plus 1 is equals to secant square. So I change this to become secant square theta. Okay, d theta. I still don't know what's going to happen. What is the most basic form of tangent square? Sine square over cos square theta. Divide by secant square. Secant square is 1 over cos square theta, d theta. And then I'm going to realize that this is just going to be equals to sine square theta. Okay, flip the cos square on top, you can cancel. And when you need to integrate sine square, what must you think of? If you don't know that right now, please review my video of integration involving trigo. You must think of the cosine double angle formula. Okay, so sine square A is equals to 1 minus cos 2A over 2. So this is half integrate 1 minus cos 2 theta d theta, half theta minus sine 2 theta over 2 plus C. Remember to put it back, okay? Remember to put it back. Now, what to put it back? That's where the triangle comes in. Theta, so x equals to tangent theta. Theta equals to inverse tangent x. And this is going to be inverse tangent x. Okay? Sine 2 theta is 2 sine theta cos theta over 2 plus C. Okay, best is not to have x and theta together, so I'm just going to write theta over here first. That's where the triangle comes in. So now we go back to the triangle. So remember just now when we draw the triangle, right? Tangent theta is equals to x over 1. The theta is here. This is x. This is 1. This is square root 1 plus x square. The final answer is going to be theta is inverse tangent x. The 2 and the 2 cancel. Sine theta, opposite over hypotenuse. Cosine theta, adjacent over hypotenuse. Plus C. Make it nice, the final answer, it would be half inverse tangent x minus x over 1 plus x squared plus C. Okay, so for substitution, remember the first 4 steps at the start first is whatever they give you, go and differentiate. If it involves trigo, draw this triangle because this triangle is going to help you later. Okay, then when you want to have a dx, you must replace the dx with dx over du times du. If not, you can just use the cheat code, make dx a subject, it will still work. And then your trigo identity. Now how to get the secant square equals to tangent square plus 1. Sine square theta plus cos square theta equals to 1. You want to get tangent, I divide by cos square. So this is tangent square theta plus 1 equals to 1 over cosine secant square theta. Okay, and I cannot emphasize this. Okay, more enough. Alright, and this is how you do a substitution that involves trigo.